Pues muchas gracias por venir. Vamos a hablar sobre the rough waters of agent security today. Me alegro mucho de estar aquí con ustedes y poder abordar el tema de retos, cambios y corrientes en la seguridad de los agentes. El tema es reciente y cosas cambian bastante rápidamente, así que les pido paciencia. Algo que he aprendido en este ámbito es que ya no buscamos la perfección, sino suficiencia y las mejoras graduales. Es la única manera de avanzar rápidamente para afrontar los desafíos de seguridad en el ámbito de seguridad de los agentes. Muchas gracias por recibirme en este paraíso. Soy Ana, nací en Polonia, pero siento que una parte de mi alma es mexicana, así que me siento muy, muy feliz de estar aquí. Soy nadadora adicta a las aguas mexicanas, como lo podéis ver, y vamos a intentar hacer para que esta charla sea un poco interactiva, así que si alguien sabe en qué agua este vídeo ha estado tomado, podéis decirlo o intentar. Bacalar, ¿quién? Aquí. Sí, pero la primera cosa que entendí... ¿Es bacalar? Si has ido tú. Vale, perfectamente. Una llave de seguridad para señorita que lo sabía. Sí tenemos algunas, así que si no duerméis y estáis respondiendo a mis preguntas, quizás ganáis una. Sí, son llaves de seguridad que sirven para double authentication, para asegurar vuestras cuentas y datos muy importantes que tenéis. Así que, aparte de eso, también me gusta mucho jugar al tenis. Soy muy apasionada, pero sin mucho éxito, así que si alguien tiene ganar y aprovechar de las canchas que tenemos aquí, ya sabéis dónde encontrarme. En tema profesional, soy una Technical Program Manager en Google desde casi 10 años y en mi carrera me enfocaba en varias cosas. Empezó trabajando en detección de abuso como analista de datos, después empezó a trabajar en Abuse VRP, así conocí algunas personas como Omar, y empezó a trabajar con la gente que se dedicaba a la seguridad. Y me gustó mucho y así hace algunos años empezó a liderar las estrategias de vendor security y de la seguridad de web. Y una cosa que no cambia en Google es que todo cambia. Y así el año pasado me encontró liderando la estrategia de seguridad de los agentes, sobre qué vamos a charlar hoy durante esta plática. Y finalmente, hablo muchos idiomas sin hablar ninguno bien, así que lo siento mucho, pero esta charla va a ser en inglés. So let's kick this off. Why am I talking about rough waters of agent security today? A few reasons. Agents are becoming more and more powerful every day. I don't think more explanation is needed here. You're all experts in this field and you see this firsthand. As a result, new challenges and new threats keep emerging every day. Basically, the wind is constantly blowing in a different direction. And finally, we haven't sailed into these unknown waters yet. What it means is that as of today, there is no principal solution to prompt injection, the biggest risk in this area. And what we can do is to reduce that risk and the impact of a successful prompt injection attack. So imagine sailing in these waters. In these conditions, small startups are like the super fast racing boats that can very quickly change in the direction of the wind and adjust while larger companies are like these massive cruise ships that just can't turn that fast. At the same time, when the conditions evolve into a real storm and things get really bad, they are the ones that are more resilient and more secure. So before we begin, let's touch base on a prompt injection. How many of you have heard about prompt injection? Okay, plenty of hands. Would anyone be able to describe what is prompt injection attack? One hand, go ahead.
Well, basically it's the ability or the bad ability to make the IA do something wrong that is not necessarily programmed to do. So go against the original purpose of the IA.
Excellent. Please, a security key for a gentleman with a great response. Very well. I mean, all I can add is that it's also around adding malicious instructions hidden within the process data, like files, email, queries, to trick the model that agent is using and hijacking its planning and reasoning processes. And then obviously to execute attacker commands using users' authority, which we give through agents. For example, an agent processing a malicious email might be manipulated into leaking user data or performing a requested task. So remember that because it's going to be an important part of the whole discussion. With that, let me quickly walk you through the agenda. We're going to talk about the promise of AI agents, key risks associated with those, core principles for agent security, Google's approach to hybrid defense in depth, and the future, and navigating AI security safely. Most of the contexts and concepts that I'm going to describe today are based on this white paper that explains everything that I'm going to talk about in more details, so feel free to take a look. It's been published by my teammates, and before we begin, last thing, what I'm going to talk about is brand new, and the field is brand new, and all the concepts are brand new. That being said, the team that is behind this has combined together decades of experience in traditional security. So the approach that I'm going to describe today will very likely remind you of all the concepts and solutions that you are all experts in. With that, let's start with the risks and the promise of AI agents. We are entering this new era of AI agents, basically systems designed to make decisions, autonomous actions, and achieve user-defined goals. They are different than LLMs. Does anyone know what's the difference between an agent and an LLM? Omar?
And the LLM is the model itself.
So what Omar said is that agents can take decisions and LLMs generate content. So agents are much more powerful. They leverage AI reasoning to interact with other systems, execute tasks, ranging from simple automation to complex multi-step planning, such as researching a given topic, or drafting an email, or patching a vulnerability. This increasing capability and autonomy provides a massive amount of opportunities, value, and is already reshaping the business and how we operate today. I mean, I'm sure you are all already heavily relying on agentic solutions, so no more explanation is needed here. But this rapid development of agent frameworks, such as Google Agent Development Kit, as well as open source solution, is actually signaling us a move towards some sort of a fleets of agents that can operate at scale rather than isolated instances. That means that this is introducing another unique and critical security challenges that will create plenty of work for many of us for the years to come. And more closer to home, obviously, this era comes with the promise of agentic code security, automated vulnerability detection, fixing, scaling, and automating code security. We've been talking about this a lot, how AI is going to take our jobs and so on. I'm not going to talk about that. I'm going to talk about the other angle of how this is a risk for us and a problem for us and how it creates a job. But you know very well what are the opportunities here. So what does this promise mean in terms of security risks, right? To understand these unique challenges, I would like to start with describing the mental model and some sort of a common agent architecture. Obviously, details will vary from an agent to another, but these are several broadly applicable concepts that are commonly used across agentic architecture design. I believe that understanding this architecture will help us to identify what can go wrong at each step and where are potential flaws. So let's just quickly discuss this step by step. We will start with input perception and personalizations. Agents begin by receiving input. This input can be either user instruction, like a typed command or a voice query, or contextual data gathered from the environment. Think about sensor rendings or recent documents, any kind of input. This input can be multimodal. That means text, image, audio, everything. And this is then processed and perceived by the agent and often transformed into a format that AI model can understand and reason. What is the security implication of that component? A critical challenge here is reliably distinguishing trusted user content and trusted user commands from potentially untrusted contextual data and input from other sources. Think about data that agents can read on an external web page, for example. Failure to do so opens the door to the prompt injection attacks, where basically the instructions hidden in the external data can hijack the agent. And that is why it is critical to carefully separate different input streams within agent architecture. So key questions to consider with regards to that when designing an agent is basically what types of input does the agent is going to process? And how can we clearly distinguish user input from untrusted ones? Does the agent act immediately or does it act asynchronously? Can a user be there to provide an oversight? Is the user able to inspect, approve, and revoke permissions for an agent actions? And if an agent have multiple users, so let's say teams, how does it grant the right user the right permissions and keep users' memory isolated? Let's move down through our schema and look at the systems instructions. So the core model on a combined input operates on a combined input that combines the input from the user together with a systems instructions. These are, for example, defined agent purpose capabilities and boundaries with specific user query and various data sources like agent memory or externally retrieved information. What is the implication of security instructions from our perspective. Well, the crucial measure involves clearly separating these different elements within the prompt, maintaining a clear distinction between what are these trusted systems instructions and potentially untrusted user data or external content is key, again, to mitigate prompt injection attacks. Next, we have reasoning and planning. So the process input combined with system instructions, defining the agent's purpose and capabilities is fed into the core AI model. We go one level down, basically, and the model reasons about user's goal and develops a plan. This plan is a sequence of steps involving information retrieval, tool usage to achieve it, and this planning can be iterative, with plans being refined and new information or tool feedback. The security implication of that, the key point and the key challenge is, from security point of view, that LLM planning is probabilistic and not deterministic. That means that this step is completely unpredictable and hence prone to errors from misinterpretation. A common practice here is iterative planning, some sort of a reasoning loop, that's how it's called. And obviously that introduces another risk, where each cycle provides an opportunity for a fraud logic and divergence from the original intent of the prompt, hijacking by malicious data, potentially compounding issues. As you can imagine, that means that agents with high level of autonomy undertaking complex multi-step tasks and iterative planning present a significantly higher risk, demanding much more robust security controls. So what are the key questions to consider here? How does the agent handle ambiguous instructions or conflicting goals? Can it request user confirmation or clarification? What is their level of autonomy, and does the agent have planning and selecting which plans to execute? Are there constraints or plan complexity or length? Does the agent require user confirmation before executing a high-risk task or an irreversible action? So with that, let's move one level down, orchestration and basically tool use. To execute the plan, agents interact with external systems or resources that we call tools. These could be through APIs for sending emails, querying databases, accessing file systems, controlling smart devices, or even interacting with a web browser, because we have browser agents too today. What happens next? The agent selects the appropriate tool and provides the necessary parameters based on the designed plan. The security implication of this stage is that this is exactly where rogue plans turn into real-world impact. Each tool grants the agent powers, uncontrolled access to powerful actions such as deleting files, making purchases, transferring data, is obviously highly risky, and the planning phase, if the planning phase is compromised. So to make sure to secure this part, we need robust authentication and authorization for the tool use, ensuring the agent has appropriately constrained permissions for the task at hand. Questions to consider here is, for example, is the set of available agent actions clearly defined? Can users easily inspect those actions, understand their implications, and provide consent? How are actions potentially, with potentially severe consequences identified and subject to controls or confinement? And what safeguards prevent agent actions from improperly exposing high privilege information. The next component is agent memory. Many agents maintain some sort of memory that enables them to retain context from previous interactions, store learned user preferences, or remember facts from previous sessions. Memory can become a vector of persistent attacks. Many of you are experts in web security, so you know very well what's a stored XSS. That's basically the same concept, right? If malicious data containing a prompt injection is processed and stored in agent's memory, it could influence the agent's behavior in the future in unrelated interactions. Memory implementation then must ensure strict isolation between users and potentially different contexts. Users also need transparency and control over agent memory. And lastly, going through the schema, we go up. Response rendering. This stage takes the agent's final generated output and displays it in a format within the user's application interface, such as a web browser or a mobile app. What can go wrong here? If the application renders the output without proper sanitization or escaping based on content type, it opens door to all wide range of classic web vulnerabilities like cross-site scripting or data exfiltration. That's why we need robust sanitization in the rendering component. So again, a few questions to consider when designing your agents. It's basically whether memory is isolated between different users and contexts to prevent data leakage or cross-contamination. What stops stored malicious input from causing persistent harm? What sanitization and escaping processes are applied when rendering generated output? And how is rendered output, especially generated URLs or embedded content, validated to prevent sensitive data exposure? So you probably already have an idea of the risk Pandora box we are about to open, entering the space of agents. We think that the design of agents that we just discussed, combined together with their powerful capabilities, exposes users to two major classes of risks: rogue actions and sensitive data disclosure. Let's dive into those. Rogue actions are unintended, harmful, or policy-violating agents' behavior, and these are a key risks for AI agents. The root cause of prompt injection, the root cause of rogue agents is prompt injection. So these malicious instructions that can trick agents to execute commands under user authority. Rogue actions can also occur without malicious input due to fundamental misalignment or misinterpretation. Just like human, agents can make mistakes. Agent might misunderstand ambiguous instructions or context. For instance, an ambiguous request, do we have a TROPICON agent? We have, okay, cool. So an ambiguous request to the TROPICON agent could be email TROPICON participants without an update about the agenda. Such cases could lead to potentially selecting the wrong contacts and inadvertently sharing sensitive information without malicious intent. Such cases are due to misinterpretation, not external compromise. Additionally, unexpected negative outcomes can arise if the agent misinterprets complex interactions with external tools. Think about forms, buttons, and all these complex user interfaces of websites. that could potentially lead to accidental purchases or unintended data submission when trying to execute a planned action. The impact of any rogue action scales directly with agents' authorized capabilities and tool access. There is obviously here a potential for financial loss, data breaches, system disruption, reputational damage, and with agents controlling our home, even physical safety, and these risks escalate dramatically with the sensitivity and the real impact of the actions that agents are permitted to take. The second risk that I'm going to talk about is sensitive data disclosure. It involves an agent improperly revealing private or confidential information due to data exfiltration. This involves tricking the agent into making some sort of sensitive information visible to an attacker. Attackers often achieve this by, again, exploiting agent actions, typically prompt injection. Attackers can methodically guide an agent through a sequence of actions, first tricking it to reveal sensitive data and then leaking it through actions such as embedding data in a URL. Data can also be leaked by manipulating the agent's output generation. An attacker might trick the agent into including sensitive data directly into its response, text or markdown. If this output is rendered insecurely by the application, the data can be exposed. This can happen through crafted image URLs hidden in Markdown and can also lead to cross-site scripting. The impact of data disclosure is severe, potentially leading to privacy breaches, intellectual property loss, compliance violation, or even account takeover. And the damage here is often irreversible. So let's go back to our architecture and try to map those risks. Can you see the numbers? Cool. So any idea of what is 1 and what is 2? Oops, too fast. Can you pass the mic?
Number 1, raw actions. Number 2, sensitive actions.
No, almost. Second try. I see the hand there.
Number 1, rogue actions, and number 2, sensitive data disclosure?
Yes, perfect. Security key for you. Okay, I should start moving faster. So these two risks melt together in what we call lethal trifecta, which refers to dangerous combination of sensitive data, untrusted content, and actioning capabilities. This is the worst of the worst, basically. Does that mean we should not swim into the rough waters of agents? No, absolutely no. We just need to swim with the boys to secure us, and that's what we are going to talk about now. So all these things that we talked about, let's now think about how we can mitigate those risks and challenges, and what are clear, actionable solutions that we can implement. To mitigate the risks of agents while benefiting from their potential, we propose agentic product developers to adopt 3 core principles for agent security: human controllers, limited powers, and observable actions. That's exactly what I'm going to talk about now. Agents must have well-defined human controllers. That means that agents typically act as proxies for humans, inheriting their privileges to access resources and perform tasks. Because of that, they should also operate under human oversight and have a well-defined, controlled user. This principle means that the systems must be able to distinguish instructions originating from a user versus other input, especially potentially untrusted data processed by the agent. Actions that are critical or irreversible, such as deleting large amounts of data, authorizing significant financial transaction, must require explicit user confirmation. Things get more tricky when multiple users are involved. They need distinct identities and clear authorization models to prevent unauthorized cross-user data access or user triggering actions impacting potentially other users by mistake. Users should have a tool to grant more granular permissions when that is the case and when the agents are shared. Next, we have agents' powers. Agents' powers are basically actions that an agent can take and the resources it can access. They must be carefully limited in alignment with its intended purpose and its controlling user. General agents need mechanisms to dynamically restrict their capabilities at runtime, ensuring only relevant permissions are acting for any given query. For example, disable file deletion when the task is creative writing or researching a certain topic. This principles goes beyond the traditional least privilege by requiring an agent's permissions to be dynamically aligned with its specific purpose and a content user intent rather than being statically minimized. This distinction is crucial because model-based agents operate potentially in unbounded environments and can make reasoning errors. Requiring context-aware limitations that go beyond the typical scope considered for human users or traditional software. Agents must be prevented from escalating their own privileges as well, and users must retain ability to inspect and revoke the authority delegated to an agent. Implementing this requires adapting and strengthening fundamental authentication, authorization, and auditing infrastructure for agents, including creating agentic identities, granular permission systems, and secure management of scoped credentials, such as OAuth tokens. And the last principle is about agent actions needing to be observable. Effective debugging, incident response, and require user to understand and rely on transparency into agent activity. We cannot ensure an agent is acting faithfully or diagnose problems if agent is a black box. Because of that, agent actions planning processes must be observable and auditable. Similar with the access to the tools. This requires implementing logging across agency architecture to capture critical information. And also logging, obviously, must be done securely to protect sensitive data within the log themselves. Effective observability also means that the properties of the agent actions and those that an agent action that can be taken must be clearly described. This metadata is crucial for automated security mechanisms, but also for human reviews. And finally, user interfaces should be designed with transparency, providing users insights into agent's thought process, the data sources it consulted, as well as the action it takes, especially for the complex and high-risk ones. So the controls in scope here, it basically comes with a need for investment in secure infrastructure, centralized logging and APIs that expose actions characteristics understandably. So just to remind you, 3 main concepts: human controllers, limited powers, observable actions. Let's go back to the architecture and the schema. Again, can you see the numbers? 1, 2, 3. What is 1? Human controllers, very well. security key for you. Now we have 2 and 3 left. Limited power, very well, yes. And 3? Observability there, yes, very well. Cool, so you're not sleeping after all. I'm very happy to see that, okay. So, excellent. Given the limitations and the nature of AI models and practical impossibility of guaranteeing perfect protection against all potential threats, what Google employs is a defense-in-depth strategy and a hybrid approach for a holistic risk reduction. And this approach combines deterministic security measures with dynamic reasoning-based defenses. This defense-in-depth approach relies on enforced boundaries around the AI agent environment to prevent worst-case scenarios, acting as guardrails, even if the agent's internal reasoning process becomes compromised by sophisticated attacks and unexpected input. This is basically limiting and preventing that worst-case scenario. This multi-layered approach recognizes that neither purely rule-based systems nor purely AI-based judgment are sufficient on their own. Instead, we need to combine them together. Obviously, runtime policy engines also have limitations. Defining comprehensive policies for vast action ecosystems is a complex and difficult to scale. Moreover, policies often lack deep contextual understanding. A rule might block a legitimate action or allow a harmful one without understanding the context or anticipating, or if the policy writers haven't anticipated it. For instance, sending an email after reading a document, sometimes that can be desired because we want to summarize it and send it, and sometimes it can be harmful and leading to data exfiltration. This can be very nuanced, and that is why a simple static rule is just not enough and struggles with this level of context. And that is why we need a second layer, reasoning-based defenses, to complement the deterministic guardrails and policy engines and address these limitations in handling context and novel threats. The second layer that we propose, introducing reasoning-based defenses. These are techniques that AI models themselves use to evaluate inputs and outputs of the agent's internal reasoning for potential risks. This strategy aims to leverage model superpowers to make the agent's core reasoning and planning processes more resilient and more robust to manipulation. One of the common techniques here is adversarial training, during which basically in the model's development phase, we expose an agent to numerous examples of attacks, such as various prompt injection. And then this training process teaches the model the desired safe response, and often how to recognize and ignore malicious instructions embedded in the data or flag them for additional scrutiny. Another technique involves specialized classifiers. These are typically smaller AI models that are specifically trained to act as security classifiers. Functioning just like security analysts, classifier model examines the input or output for signs of an attack, detecting instructions like language within the input or process data, and checking for malicious patterns. Additionally, models can be employed for analysis and prediction by analyzing the agent's proposed plan or action. A model might predict the probability of the agent leading to undesirable outcome or flagging high risk. The strength of the reasoning-based defenses lies in their potential for dynamic behavior and context. These are exactly the weaknesses of the deterministic solutions we just talked about. So models can learn to recognize more nuanced or evolving malicious patterns, and they significantly increase the difficulty and the cost for the attackers. However, these strategies are not deterministic and cannot provide absolute guarantees. Models can still be fooled by novel attacks, and their failure modes can be unpredictable. That's why we need the deterministic safeguards to prevent the worst case scenario, and we need this to work in concert together. The last layer relies on validating your agent security. Assurance efforts supporting both layers are continuous assurance activities, such as regression testings, ensuring that fixes remain active, variant analysis, proactively testing variation of known threats to anticipate the future ones and their evolution, and complementing automated testings with human expertise is crucial. So think about AI red teaming, simulated attacks, user feedback, security reviews, security audits, and so on. These all provide diverse perspective and enable us to uncover new weaknesses. And also Google VRP. And that's something I'm going to dive into in a few minutes. So to summarize everything, AI agents present a transformational opportunity, but also a challenge. They have an immense potential for productivity and innovation. However, their autonomy and their powers also create a big risk. And that is why we need a proactive and exhaustive approach towards security. The risks of rogue agent actions and sensitive data disclosure are incredibly high and originate from the core agent characteristics, like reliance on complex AI reasoning and interactions with external data and tools. Relying solely on traditional measures designed for predictable software, or conversely placing blind faith in the imperfect reasoning of current AI models is not enough to meet this challenge. Instead, we need a hybrid solution that combines these two. These approaches grounded in the several fundamental principles that agents must operate under well-defined human controls, their powers must be limited according to their risk, and their actions and planning must be observable. The security of AI agent is not a problem that can be solved at once, but this is going to be an ongoing discipline requiring sustained investment and adaptation. Things keep changing here all the time, so continuous vigilance, rigorous testing, and commitment to refining these hybrid approaches is key. You can learn more about the solutions, the controls, and different concepts that I'm talking about today on this website. A lot of things is not there yet. As I said before, the field is new, and we'll keep updating this as our research continues and as we get better. And how can we get better? Let's talk about the AI VRP and new opportunities here. Eduardo talked about the Google Back Bounty program and a VRP and different challenges. There was quite a few talks about potentially difficulties in this space moving forward with all the agentic development. That being said, for now, what we are doing is launching a new VRP focusing exactly on the threats and the new vulnerabilities that I was talking about just before. In that keynote yesterday, Ben was asking if AI is going to take over our jobs. Maybe at some point in future, but for now, from my perspective, it gives us plenty of things to do and new problems to solve. Because of that, at the end of last year, we announced the launch of a brand new AI VRP. You can scan this code to learn more about the program. Let me very quickly go through this. I will keep it short. Many of the weaknesses that we just talked about are in fact the issues we are now considering as in scope for AI VRP. Receiving your reports on these topics helps us to improve our security controls that we talked about and refine them, identify the weak spots in our own ecosystem. Insights from these reports are really key and help us to address the challenges that we were talking about. And not only that, we reward them very generously with payouts for ROG actions in flagship products going all the way up to $20,000. That's a lot of mezcalitas, which if topped with bonuses and multipliers can go all the way up to 30K. And there is one more reason to join our Bug Hunter community. We make awesome events, and we did one in Mexico last year, and
This is one of my favorite events that I look forward to every year, and it's because we engage with all the security researchers that are kind of an extension of our engineers. We invite them to basically hack our products, and then we give them money, and we get a lot of value out of basically learning what are the hotspots in our products that we should focus on, get some of that validation.
So I've been coming to Boxwatch for like past 4 years, I guess, and this has been amazing because people here are like super smart. This place probably has the smartest people in the world. Just meeting with them and talking to them is such an opportunity that I look forward to. That's why I'm coming back to Boxwatch.
Muy feliz con esa experiencia, ya que el poder conocer y hacer networking con gente de Google apoya mucho en el ámbito laboral, aprender sobre cosas de ciberseguridad y más que nada conocer acerca de estos temas de primera mano.
Well, the thing that stands out for me is the game and the passion that all the Google people have put into the event. You can see how much they want this to be a good and interesting competitive event, and that's why we are here. That's why we qualify, and that's why we compete.
So very quickly, I know that Pedro and Paulina are going to kill me because I'm already over time, but Escalade is about 3 different events. One is for our Baxwood researcher, another one is for our CDF players. I'm looking at all the CDF players here in the room. We'll have qualifications very open very soon, and finals are happening again this year. And lastly, INITG. A workshop for students designed to encourage students from diverse backgrounds to continue their careers in the field of cybersecurity. And that one is particularly close to my heart because that's the one that I lead. We did it in Mexico City last year, and I really, really hope we can do it in Mexico. If not this year, very, very soon. Sorry for going over time. We're not going to play the video again. Thank you so much for listening, and thank you so much for not falling asleep and responding to my questions.